Let us see the types of polymerization reactions. See, as we have explained you, the polymerization reactions mainly are of two types: additional polymerization and condensation polymerization. The additional polymerization is also called chain growth polymerization because in this the chain grows, the monomers start adding to one another and start forming a long chains, and this is how it is called a chain growth polymerization. The chain growth polymerization mainly takes place by free radical mechanism. As we know from the class 11, the free radical mechanism takes place in three steps. The first includes the chain initiation. For this we uses photosensitizers like benzoyl peroxide, which when exposed to the light is the one which forms the free radicals. Now these free radicals, like this one, it readily changes to give us what? Phenyl radical along with CO2. Then what happens is this phenyl radical combines with, like suppose this ethene molecule by homolytic fission to form C6H5 CH2 dot. So this is how we have got now the ethylene radical, and now it will again combine with one more ethylene molecule to form, and this is how the chain starts increasing. So this is called your chain propagation. And the third step, the chain termination, will involve what? The combining of these two types of molecules, like this one, leading to the formation of C6H5 CH2 like this one. I'm writing it down here, C6H5 at the other end. So this is how we have got your polyethene or your polyethylene polymer. So this is a simple way of representing or explaining you the mechanism, which is a free radical mechanism involving chain initiation, propagation and termination, three steps. Now let us see some important examples of the additional polymers. We will see their preparation, how they are prepared. The first example is polythene. The polythene are of two types, two categories. One is called LDP, it's called low density polythene. Another one is called HDP, it's high density polythene. Now let's take first LDP, low density polythene. When the ethene molecules are subjected to a very high pressure of 1000 to about 2000 atm pressures, and they are subjected to 350 to 570 Kelvin temperature. These monomers they form a long polymeric chain which are called low density polythenes. Why we call them low density polythene? Because they are highly branched polymers. As a result, they cannot be packed together compactly, so that's why they're having a low density, so that's why they are called low density polythenes. They are tough but yes flexible. They are inert. Now it is it's a good insulator, so it is used in making electrical wires, squeeze bottles, etc. Then we have high density polythene, the second type. The high density polythene is the polythene which is obtained, of course, from ethene molecule, but it is consisting of what? Linear polymeric chains of these ethene monomers. So we call it high density polythene. Now linear polymerization takes place in the presence of a catalyst which is called Ziegler-Natta catalyst. Now, Ziegler-Natta catalyst is a catalyst which is aluminium, triethyl aluminium and titanium tetrachloride, the combination of these two, which leads to what? Linear polymerization of these ethene molecules, giving you high density polyethene. See, these are linear chains, so packed compactly, having high density, so they are very tough, strong, inert, yes, and that is why they are being used in making what? Your buckets, baskets, dustbins and pipes. So this is what you have, polythene. The second example of additional polymers is your Teflon. Teflon is basically is having monomer CF2 double bond CF2. This is called tetrafluoroethene. Now this on polymerization gives us CF2 which is called polytetrafluoroethylene PTFE. Now this polymerization is done by free radical mechanism or in the presence of persulfate catalysts under high pressure, and the polymer obtained is very resistant to all the reagents. That is why it is used in making non-stick cookwares. So this is what we have, Teflon, tetrafluoroethylene polymer. So we call it polytetrafluoroethylene. Then we have another polymer, which is another example of this additional polymer, a very important additional polymer, which is called polyacrylonitrile PAN. Polyacrylonitrile. This CH2 double bond CHCN is called acrylonitrile. Now this on polymerization forms polyacrylonitrile PAN, which is also called Orlon. Commercially, it is called Orlon, and it's a very it's having very high tensile strength. It's a long fiber-like polymer which is used in making your used as an artificial wool in making carpets and your woolen blankets, etc.